let's start. We'll listen you, ask questions and so on.
Paul, thank you, and thanks for having me, and you guys, thanks for coming.
Unfortunately, here we have a lot of seminars during this period, so.
No, it's okay, it's okay. That way.
Nevertheless, it's very interesting for us.
No, none of you have heard this well except for Ludmila, but in any case. So then I will go slowly. We enjoyed just as many questions as you want, and yeah, whatever we get, we get. So this is what.
Right, for the whiteboard.
There's a pointer here. No.
No, this is only for whiteboard. There is no special.
So the goal of this talk, there are two goals here. One is technical, which is showing you what you see here. That is, how to do pricing or how to improve pricing when you are using Garch and ALSB. I will not touch it as underlying. How to do hedging, and then there is another, not technical but moral goal, which is to show you that actually the difference from the point of view of there are these two intellectual schools of thought, and we were discussing that right now with Emmanuel. You have this discrete time approach to think and this continuous time approach to think, right? So this difference in the mathematical finance context is very acute from the point of view of both techniques that we have available to treat the problem, because usually discrete time is associated to econometrics, financial time series, and basically statisticians. And then when you go to continuous time, it's a completely different story. Because there the community that you have is people who do, the stochastic calculus, and you have this wonderful set of mathematical tools that you can put to work in these applied problems. But you see, these are different techniques, these are usually different people, and they claim that the results are different. So one of the goals of this talk is to show you that, there is actually not much difference, first from the point of view of results, and that there are ways to actually take advantage of the good things that you have in both approaches, right? So in the econometrics case, you have all the tools that come with good estimation techniques, and you can do statistical inference. You can anticipate what is going to be the quality of your results. And again, when you are doing continuous time, there are extremely powerful tools that you can use. So there are two parts of the talk. The one in which I will spend most of the time is this pricing part, in which I will talk about the interplay between the discrete time and continuous time. And then we will go to hedging, and hopefully I will get up to here. Okay. So. I don't know what your background is, the people who just came, and I know that here there are financial mathematicians and some econometricians. So the idea here is basically to work with derivative products, contingent products, whose underlying is modeled by something more sophisticated of what is done for Black-Scholes, right? So as you know, the Black-Scholes formula for European derivatives is based on assuming that what you have as underlying asset is something that is modeled by this normal Brownian motion, and or geometric Brownian motion, and which has an explicit solution, but assumes that your volatility is constant, and so is your trend, right? If you talk to econometricians about it, they're going to scream murder, because there are so many empirical proofs that that is not the case, that, they will immediately tell you that this is not a good model, right? So, and actually it's something that is well known, because even people who do just purely mathematical finance in the continuous time setup, they are aware of the empirical inaccuracies that come out of the Black-Scholes formula. namely this volatility as well. That is inconsistent with the fact that you have constant volatility. So if you want to improve the models for the underlying, there are two ways to do it. Again, continuous time. So you just come up with more general continuous time or more general continuous time stochastic processes. So that's what you have with heavy processes by introducing jumps or using stochastic volatility models. And the approach that you will see here, at least in the first part of the talk, is to go time series. So both categories or both techniques are recent, and the time series case, it was developed in the 70s. So it's this and it actually was created for different purposes, which had to do basically with many disciplines in social sciences. So it is only more recently that it was applied in financial econometrics, right? So mainly after the works of Engel